x goes to 25 of the square root of x minus 5 all over x minus 25. So again, finding limits, we are just finding limits right now. We're going to talk about trig limits and squeeze theorem here. So if I want to find this limit, what's the first thing I'm going to actually do to find this limit? You're going to plug it in. So your techniques that you're going to use, and there's actually in your book some helpful techniques. If you read through the section, you should see on the bottom of like page 62, on the bottom of page 62, there's a strategy for finding limits. So page 62 gives you strategy for finding limits. It says, learn to recognize which limits can be evaluated by direct substitution. So those are all the ones listed in our theorems 1.1 through 1.6. And basically, we just try direct substitution first. So your first option would be just direct substitution. Okay, so that's the first technique I'm going to try. Why? Because I hope that I can find the limit that way. That's the easiest, isn't it? Plugging 25 in for x. So I'm going to try plugging 25 in for x and just seeing if that will give me the limit. So on the top I get 0 and on the bottom I get 0. So I did not luck out in that way. What is this called again? This is called indeterminate form. Indeterminate form, which does not mean no limit. It means back up, do some algebra to this, and then try substitution again. Okay? And that's actually the second strategy in your book on page 62. It says, if the limit of f of x as x approaches c cannot be evaluated by direct substitution, try to find a function that agrees with f for all other x other than x equals c, blah, blah, blah. That means try to do some algebra to this, okay, to make it look different. You don't want to change the function. You're trying to simplify it. Now, this is a technique that I'm actually going to factor the bottom of this. And you may not have ever thought that you could factor the bottom of this. Another thing you could use is something called rationalizing the numerator. Can you rationalize a numerator? Yeah, you can. You can rationalize a numerator or a denominator. So there's two ways to rewrite this function. I'm actually going to factor the bottom, okay? I'm going to factor the bottom as a difference of squares. So what I'm doing is I'm going to my technique is I'm going to simplify or rewrite my function square root of x minus 5 over x minus 25. I'm going to do a little algebra to this. So here's how I'm going to think of the bottom. I'm going to think of the x as, isn't x the same as the square root of the square root of x squared? Okay? And if I think of it that way, doesn't this become a difference of squares? And so then I could factor it. I'm just going to leave the top. Then I could factor it as the square root of x minus 5 and the square root of x plus 5. Because isn't the square root of x times the square root of x, x? Okay. And then what's going to cancel here? Square root of x minus 5. So the function I actually have now is 1 over the square root of x plus 5. So I've rewritten the function, and now what I'm going to do is try taking the limit as x goes to 25 again. So now I'm just going to try direct substitution again and see if it works this time. All right, so now if I plug in the 25, I get 1/10. Plug in 25, the square root of 25 is 5. 5 plus 5 is 10. 1/10 is my limit now. So the answer to this question is 1/10. Because this function is not different from this one, it's just simplified. All right, so that's one of the techniques you may have to use today to simplify. So I'm going to do two other examples that are a little more challenging of things that you may have to do to come up with to be able to use direct substitution. And then we're going to look at a couple of limits that we are to memorize, and use those to do some trig problems. So let's now take a look at finding the limit as delta x goes to 0 of, I just want to pick out a pretty ugly one. Gotta like the delta x, right? Now tell me about delta x.
Change in the x value?
It's the change in x value. It is a, what was that, Corey? It is its own variable. It is a single variable, okay? Delta x are attached together, okay? All right, so I need to find the limit as delta x goes to 0. So if I do direct substitution, what am I directly substituting 0 in for? Delta x. So when I do that, I get x plus 0 squared minus x squared all over 0. What is that going to work out to be? 0 over 0, which is not 0. It doesn't mean does not exist. It means back up to this, do some algebra. What type of algebra can I do to this function? I can FOIL, I can distribute, I can get rid of parentheses. Okay, that is should be an obvious thing. So if I want to FOIL or square x plus delta x, I'm going to write it twice. And I'm going to multiply the first two, that's x squared. Multiply the outer two, that is plus x delta x. Multiply the inner two plus another x delta x. Multiply the last two, that's plus delta x squared minus x squared. Notice I'm just kind of ignoring the bottom right now until I get the top all simplified. Now I can combine the like terms. What goes with x squared? Okay, and what happens to them? So those are going to go away. And what goes with x delta x? And how many of those do you have? 2x delta x plus delta x squared. And now I can put the over delta x. Okay, I'm still not done simplifying this. I want to continue simplifying this. What can I factor out of the top? Delta x. All right. And now what can I do? Cancel the delta x. So now what function am I actually going to use substitution on now? 2x plus delta x. And when I plug 0 in for delta x, what is my answer? 2x. So the limit as delta x goes to 0 of this is actually just what? 2x. Okay, you don't have to get a number. It's okay. So the key on the delta x problems, you're probably going to get 0 over 0 when you do direct substitution. Get rid of the parentheses. All right, one more of these, and this is one I know you're going to like. It's fractions. Yep. Okay, now I tried to write this a little bit the way the book has it to start with. So you have to understand this is a fraction, 1 over 2 plus x minus 1/2, all over x. And we want to find the limit as x goes to 0. So we try what first? Direct substitution, putting 0 in for x. So I'm going to have 1 over 2 plus 0 minus 1/2 all over 0. What am I going to get?
All over 2.
Oh, all over 0. I said 0 and wrote 2. So what am I going to get? 0 over 0. Which is what's it called? Indeterminate form. Learn to say it, okay? Learn to say it. Just mess it up 50 times, you'll eventually get it right, okay? Indeterminate form. So What does that mean? What do I have to do with this mess? I need to simplify. Now, are there any parentheses I can get rid of? Can I FOIL it? Can I rationalize? No. Okay. So, but what can I do with the two fractions on top? 1 over 2 plus x minus 1/2. What can I do with fractions? Get a common denominator. So what is the common denominator here? What would be on the bottom? No, 2 plus x is not the common denominator. You never add things to get a common.
4 plus 2.
Whoa, whoa, whoa. I have a question. If I were going to get a common denominator between 1/7 and 1/3, what would you do? 7 times 3. Right? So what are you going to do with these two things to get a common denominator? Multiply them. Don't even distribute them. You're going to waste your time. How do you write the product of these two? No. Don't distribute. 2 parentheses 2 plus x. Common denominator. Never multiply out a common denominator. Always find common denominators by multiplying. Because that's what you wouldn't have said the common denominator is 10, would you? No. Don't try to combine these at all by adding. This 2 is totally different from this 2. This 2 is married to the x. This 2 is by itself. All right? The only way to find a common denominator is to multiply. Don't actually multiply. Write them next to each other. It's easy then to see what you have to do to the top to go from this denominator to this one. I need to change this denominator into that one. So what do I have to multiply top and bottom by? 2. I have to change this denominator into that one, so I multiply top and bottom by 2 plus x. So now, 2 times 1 gives me what on the top? 2 minus 2 plus x. Oh, minus the quantity 2 plus x. I'm actually multiplying a -1 times each of those. That is the biggest mistake that students make, forgetting parentheses or distributing negatives. Okay, so now I have the common denominator of 2 times 2 plus x. Distribute the negative, so that'd be 2 minus 2 minus x, which gives me what on the top? 2 minus 2, it's negative x. Can I simplify this? Oh, whoops, now, what was I only dealing with? The top. So basically I've got this whole mess over x. How do I divide by x? Multiply by the reciprocal of x, which is 1 over x. And what happens to the x's? They cancel. So what function am I really taking the limit as x goes to 0 of? -1 over 2 times 2 plus x. So if you try substitution now, what do you get? What's 2 plus 0? 2 plus 0, please. 2 times 2. For an answer of -1/4.